And I think we are live. So welcome everyone. Welcome to another lecture of the F# Essentials initiative that is inside of Amplifying F#. My name is Edgar, and today together with Ian Russell, we will continue the lectures where we left last week. So just a little bit recap. This is a free online course that is based on Ian Russell's book, and is the link for the session will be always on this page, and this link will be updated so you can join every Wednesday. You will be able to join the latest meeting, and we will also update the dates and all of that. So last week we did the introduction and setup, and we also talk a little bit core types in F#. And today we are going to talk about introduction to pattern matching and functions. So yeah, I'm really looking forward to that. So before we start the session, I will also wanted to mention that Amplifying F# is an initiative that wants to encourage developers to collaborate and to make a difference in F#. And for that, we have on Fridays normally sessions that are really targeted to focus specific issues like tooling issues, fix some issues in the compiler, and also amplify or showcase some of your projects. So if you go to the amplifyingfsharp.io, and on the sessions, you will see that we have more than 40 sessions already during the last year, where we cover different topics like tooling issues, enhancements on Fantomas, shout outs to projects, and a different range of topics that are all part of the evolution and the innovation in the F# ecosystem. So yeah, that is all I wanted to mention. And with that, I will give it to Ian to start the second lecture. So let me stop sharing my screen. And yes, it's all yours.
Okay, hopefully everybody can see that. My screen up. Okay, so welcome to the second session. So the agenda for today is I'm going to do a quick recap on session 1 over some of the things that we covered, and then we're going to move on to we're actually going to do more pattern matching because we did some pattern matching last time, particularly things like discriminated unions and the pattern and the match expression. But I'm going to have a look at how to use a match expression with tuples and records in this session. And then we move on to functions. Obviously, functions is a big topic in F# in all functional languages. So this one's going to be really the foundations of functions. So everything's going to be relatively simple. So everything's going to line up properly. So the outputs from one function is going to match the inputs for the next functions, that sort of thing. So it's relatively simple at this stage. As we go through the series of sessions, they will get harder. They will get slightly more complicated over time. Particularly, I mean, the next session will be quite interesting because that's we're going to look at nulls and exceptions next time. So that's going to be where you're going to have to build on all of this. So that's where we're heading with this particular session. So quick recap on session 1. So we started off with types. So the important thing to remember with F# is it's .NET. It's strongly typed, even though it doesn't always appear to be. It has been. So I've deliberately made an effort so far to make everything typed and make it look like it's typed all the way through. But today we'll start moving away from that a little bit. So we had a quick look at primitives. So all of your decimals and bools and all the rest of it. One of the things that's different in F# compared to, say, C# is that you can't do a lot of implicit casting. So you can't do things like you can't add ints and decimals together. for instance, you'll get a warning, or you'll get a compiler error, sorry, from doing that. So it's very much more, you'll probably say restrictive if you're coming from C#, because you're used to things working in a nice, simple way. Stop you doing stupid things is what I'd say. So it ensures that you're actually doing what you should be doing rather than potentially throwing data away. We then looked at the 3 core base types of F#. So tuples, which are simple collections of data, generally used for things like returns from functions, but they can be used for other things as well. Records, which is very similar to C# records in a way, in that they're immutable. You have to supply all the data at the start, and they have things like property names in there. And then we moved on to discriminated unions, which is slightly different from what's available in C#. So they're an OR type. So one of the examples that I did was, I think I've got it here somewhere. So one of the examples that I did was a Boolean. So it could be, oops, take a known out. So it could be either true or false. But the important thing with the discriminated union was that the type is the Boolean, and the other 2 things, true and false, are cases. So what you're actually passing around is a Boolean. So it's not like inheritance. So it's not like having an interface and concrete implementations. You don't pass around the concrete implementation. You pass around the type, and it just happens to be a particular case. And then we use pattern matching, particularly in this case the match expression, which we've got down here, line 12, where we actually start to unwrap the cases, and so discriminated union is a closed set. So all of the data is in the set that you see on the screen. So you can't have. So again, it's not like inheritance where you can have a concrete implementation anywhere in the code base. All of the definition for that discriminated union is in the type. And then we spent a little bit of time doing some domain modeling, and part of this session is to look back again at the first 2 examples that we did with the tuples and the records. So some of the things that we did there with the with the modeling was we looked at things like type aliases. So rather than having things as just a straight primitive type, it's very easy to create something that says, well, instead of using that, I could use a domain name instead. So spend meant something to the example that we're working on. It's not very helpful, but it's slightly better than using a straight decimal. That's my README. We did actually create a function. It's very difficult to write F# code without writing functions. You can't really do anything. So we did look at that, and we also had a basic look at function signatures, but we're going to spend a lot of time looking at those today because that's very important to know. The other thing I talked about was expressions. So F# is basically full of expressions. Expressions are things that return values all the time rather than a statement. So in C#, for instance, you could just do an if statement. So if something was null, then do this, and that would be it. You can't really do that in F# because you have to cover the else case as well. So you have to cover both sides. And we did some. I took the basic example. I went from a tuple to record, and then did some discriminated unions, just trying to look at the types that we have available and trying to match the type of problem that we were trying to solve. There's no perfect solution. all the solutions worked, but they all have it's all personal opinion, really. It's as long as they meet the requirements of the feature that you're trying to implement, then it's hard to argue if one's a better approach than others. Big difference, though, for F# compared to C# is not so much the types and the syntax. It's the way that we actually write code is very different. So the fact that we can create script files, the fact that we can run code in the REPL, so we can actually run code anytime we want to, just by highlighting it and pressing Alt and Enter. The fact the compiler's running all the time is very different. So it's telling you about problems you have with your code. The other big one is as well was the fact that the order of the code matters in F#. So we define the types at the top. So if we go back to our modeling example, we define the types at the top. We then defined some functions. We then created some instances of the types, and then we use the functions. And it goes from the top of the file down. So that's very different from working in something like C#. So one of the things that I tried to get across last time was listen to the compiler. You know, we're not compiling all the time. It is automatically running in the background all the time. And if it tells you that there's a problem, listen to it. Fix it. The compiler's written by some really, really, really clever people, way more intelligent than I will ever be. You know, so if they say, do this, do it. It'll take a little bit of effort to get used to, but, you know, we'll get there in the end. Right, so what we need to do for this one is to create a new folder for session 2. And we're going to copy the code from the modeling 1 example from last time. So I'm going to copy that, and I'm going to create a new file in session 2. Called modeling1.fsx. And I'm going to paste that code back in. Or I would paste it if I'd actually copied it. Ah, there we are. It's embarrassing if you can't even copy and paste when you're trying to show people how to do things. So what we're going to look at now is we're going to look at using the match expression, so pattern matching for the tuple. So we've already got a little bit of pattern matching in place here anyway. So this is pattern matching already. So the deconstruction of the tuple. So the customer is a string, a bool, and a bool. And I've broken it down to say its name is registered and is eligible. You'll notice that the name's not actually used. So if I don't want to use that, I can use the wildcard and use the underscore. So it's just ignore, but it's discard character in this case. But so as I said, what I want to do here is to use the match expression instead of using the if then else. So what I'm going to do is I'm going to match the customer with, so it's exactly the same as we did with the discriminated union last time. And I'm basically going to follow the same idea as this for the first stage. So I'm going to copy that and paste that in. I'll comment that out. I don't need it. And oops, I need to. So I need a guard clause. So when is registered and is eligible and spend greater than. Okay. How do I clear? Sorry, I've got the Zoom thing in the way.
I think you can drag the Zoom one to the other screen if you have another screen. Just drag the thing to the somewhere else.
Right. Yeah, I couldn't scroll across because I've got the Zoom screen in there. Right. So what I've done here is a match expression. So I match the customer. I'm using the same deconstruction that I used above. And then I've got a little guard clause which says when it's is registered and is eligible and the spend greater than 100, then the discount is spend times 0.1. Otherwise, it's 0. Okay. So that's phase one. Obviously, that's not particularly useful. It's a lot of extra typing for basically no gain. What I can do instead is instead of deconstructing it into this, I can actually make it match a pattern based on constants. So I can actually say, well, I want that to be true, and I want that to be true. So I can get rid of those two. So now I've got match expression and it's matching a pattern and checking the values at the same time. It's a really powerful tool, is pattern matching, particularly this style of pattern matching. You'll notice as well that there are no red squiggles or anything over here. So I could highlight all of this code again and Alt and Enter to run it in the REPL, and everything's working. So it's a very quick change. Get used to writing match expressions. They're used all over the place. Most F# code bases tend to use them rather than if expressions. One of the big reasons for that is if expressions they're great for binary choices, so a true or a false, but not so good when you've got multiples of them. You know, nobody likes writing if then else's, you know, especially if they're nested. So pattern matching is a much nicer way to do it. So that's the tupled version. And what we'll do now is we'll do exactly the same thing for the record. So modeling2.fsx, create one of those, copy the code from the previous session. Okay, I'm going to do the same thing again. So I'm doing a match. customer with now when you're pattern matching with a record, you don't need to specify all of the properties. So with a tuple you do, but with the record you don't. So I'll do it in two stages again. So is registered equals is registered and is casing right. Okay, again, we've got the one. So is registered and is eligible and spend greater than that. Turn that into an arrow. And again, just use the wildcard for all the other cases. And that's 0. I can do exactly the same thing as I did for the tuple. And I can make them constants instead. You notice you don't have to do it for all of it. So you could have some where you're actually picking the value out and others where you're saying this is a filter. In this case, I can run them both as filters in effect. So again, I've got no error messages on the side. If I run it, use an Alt and Enter again, everything's compiling. Everything works perfectly. So as you can see, we use pattern matching a lot. So get used to it, get used to writing them, get used to trying them out. So that's all I want to do for pattern matching at this stage. And now we're going to move on to functions. So the first thing I'll do is I'll go back to actually I'll go back to where we've just been. As good a place as any. So I didn't really cover functions very much in the previous session. Obviously it's a function, it's there, but I sort of glossed over some of it just because it's obviously I was going to cover a lot more today in this session. So there are some very important things that we can take from this that you may have seen or you may not have seen. I can't remember if I did mention some of these things or not last time. So the first thing to note is that there is no return value. So the last expression, in this case, the last line, in this particular case, is returned automatically. So a function always returns something in F#. It's also standalone. So we can attach functions to two types, but we don't often do that. So it's perfectly possible to do it and legal to do it, but generally the way that most people write functional code is to keep the types and the functions separate as much as possible. And certainly as we go through, you'll see more and more of that as we go on. So a function has one basic rule, and that is there's one input and one output. So it's a hard rule, and we're going to break it once we go through this particular session. So in this case, the calculate total function has one input that happens to be a tuple of customer and spend, and has an output of total. How do I know it's a function? Because the compiler, if you look on the side here of line 11, I can't highlight it because it's part of the Visual Studio Code IONIDE helper output. You have customer star spend, and then an arrow, and then total. If you're wondering why I've got nice little arrows here, it's because I'm using a font. I think I'm using Firacode. But there are quite a few fonts out there that have something called ligatures. And what that gives you is fancy styling, like you get with this, like the greater than or equal to, and the arrow function here. So it's a minus sign and a greater than, and it just ties it up and makes it look really neat and tidy. So it's worthwhile looking at. So that's I'm pretty certain it's Firacode that I'm using.
I think the feature that IONIDE has is called inline hints, which is what
Okay.
it's kind of show you the types.
Thank you, Edgar. Okay, other things that we have. White space is important. So here I've got so everything is indented in like this. If I go and type something else further down and I indent it, so if I go what I get is a compiler warning. It's a compiler error actually, telling me that it's finished, telling me that it's a block and it should be returning something, but I'm obviously not here. So it still thinks it's part of the calculate total function. So if I now shift across, it works again. So you can sometimes get a little bit lost with this because you haven't got curly braces to delimit when a function starts and when a function ends. You have to be a little bit more careful. But once you get used to writing functions, it becomes second nature. So don't worry about it too much. Discount is a value, and it's scoped inside the calculate total function. So I can't get at discount from outside. So it's not defined outside. So it's only defined inside the function. I think that's it for now. On that, we've got a lot more to cover with functions. So let's create a new file inside session 2 called functions.fsx. Right, and I'm going to create a new function called add that's going to take two, so it's going to take a tuple of int and int. So I'm going to call them x and y. So that's pretty much the same as the last function that we had. So the calculate total. So it's a function called add that takes two ints, and so takes a tuple of two ints and returns an integer output. Okay, so if we look at the signature from the Ionide is giving us is int star int to int. So it means it takes a tuple of int and int and returns an integer output. Okay, stage two. I'll give it the same name. Okay, I've taken the types. Actually, I need to add the other type, the return type as well into that one. And then I took them away, and yet it's still telling me it's got exactly the same signature. So the default for addition is int. So the compiler has actually worked out what the types are for me. So I don't have to specify the types. It's still strongly typed, but I don't have to actually set the types on anything. That's not always true. There are situations where you do have to put type hints against parameters, but pretty much most of the time, you don't actually need the types. And this is a really hard thing for most people to grasp to begin with. So when they write code, most people will put the types against everything. It takes a long time to trust the compiler. But once you start to trust it, what you find is the actual number of types you need to specify is actually quite low. So the next one that I'm going to do is so now a space between add and the tuple. So it's not like a method in C# where you've got the name and you have to have the tuple directly attached to it. It's actually independent of the name of the function, but you don't have to have a space. Again, look at the function signature. The signature is still exactly the same. Nothing has changed. I'm going to take it even further than that. So I can write this function in a slightly different way again. Again, look at the function signature. As long as the signatures match, the functions are equivalent. Okay, so this form of parameters that we've been using here is called tupled form. I suppose they should be called tupled arguments. Okay, are there any questions on this so far? So this is quite
Yeah, no, exactly for the functions because we're starting with that, but was more about the pattern matching example that you gave. It says that it was basically just a one level deep. He was asking that David ML was asking if we could go maybe a two level deep example. So I'm preparing an example on my own on my machine, so I will post it in the chat. But I will post it. I will ask you
okay.
later.
Okay, so they're all different styles of functions, all basically doing exactly the same thing. And there's nothing wrong with this, but what you'll find is when you look at most F# code bases is that we don't really use this style of argument. What we tend to use is something slightly different. Right, so this is called curried form. Okay. The important thing to notice here is that the function signature has changed. So now instead of what we had previously, which was int star int to int, what we've now got is int to int to int. Now, if you remember, I said earlier on that there's a one rule in functions. So all functions have one input parameter and return one output value. Doesn't this look like two parameters? Two input parameters? It is two input parameters. So how does that work? Well, this is where it starts to get a little bit more interesting. So let's first of all, I'm going to take my I'm going to get rid of all of the type hints. And I'm going to try and do the same things that we did up above here. So I'm going to write this out in a slightly different way. All right, so what we've actually got is add this version of add, so the curried version of add, is a function that takes an integer and returns another function that takes an integer and returns an integer. So go back over that. So what this is doing is actually splitting it up into multiple functions. So what you've actually got is, whilst it appears as int to int to int, what you've actually got is so what it's doing is breaking this down automatically into single input functions. So in this particular case, when you supply both the arguments, you satisfy the whole function. So the obvious question coming back from that is, I've said if you supply all the arguments, what happens if I don't supply all the arguments? Let's have a look. So there I've supplied both. So if I highlight add and then run both, I get 9, which is what I expect. Oops. So if I highlight that and run this, what I get down here is int to int. So it's returning a function. So it's perfectly valid to partially apply parameters. So you can only do them in order. So you can't, so if you had a function that took a bool, a string, and an int, you can call the function with the bool, you can call the function with the bool and the string, or you can call it with all of them, so the bool, the string, and the int. You can't supply them out of order. So it's not that clever. But F# automatically curries a function for you and automatically splits it into multiple functions. But it appears like it's a function with multiple parameters, but it isn't. And the advantage of that is that we can use partial application. Partial application we will use quite a lot in F#. So it doesn't mean that you have to write all of your functions in this style. It's perfectly possible to write as many functions as you like in the tupled style, but then you can't use some of the features that we're going to come on to later on in these sessions and later on today. So those two terms, so currying is splitting a function with multiple parameters, is splitting a function with multiple parameters into multiple single parameter functions. Partial application is applying the parameters partially, so not applying all of the parameters in one go. So partial application is possible because of currying. But to do currying, you must have something that looks like multiple parameters, or a compiler that will split a tupled form into multiple parameters, but F# doesn't do that. Any questions on on this, or is that?
Yeah, we have a question in
Okay.
regards, I think, on if there's any practical use of defining for example, let add equal to fun that passes to Can you see the chat? Maybe you could would just be easy for you if you so it is the last question basically.
Is there any practical use? No, but get used to the fun arrow style of writing functions, because we're going to use them, particularly when we get onto collections in session 4. So it wasn't. So the idea of using so the question is more about this style of
Yes, exactly.
writing the function.
Yep.
So no, there isn't any practical use. There's nothing to stop you doing it. It's exactly the same as the other forms, but it's not as obvious. But this right-hand side, this style of actually writing functions, we're actually going to use later on today. So this...
Yeah, maybe that will cover the case, for example, if you want to, pass a function as a parameter and then you can kind of want. Okay. I will wait. I will wait like the rest.
Yes. So get used to looking at functions in that style, even if it's just the right-hand side. The right-hand side is the important bit. But yes, you wouldn't generally write a function out like this. You'd generally write it out in one of the other styles. If they're tupled, they tend to be written out like this one on line 5. And if they're curried, they tend to be written out more like line 15. So they tend to be the standard ways of doing that. Okay, so just to quickly go over that, so so currying is splitting a function that appears to have multiple parameters into multiple functions that take single parameters. And then partial application is applying a subset of the parameters to that function. But it has to be in a particular, in the order that they're defined. So you can't do them out of order. So the next one I had on my list of things is composition. So I've written a little example. So we've got a simple record type that has 3 properties: ID of int, is VIP of bool, and credit is for decimal. And then I've got 3 functions. Don't worry about the internals of the functions. What we're actually interested in is the signatures. So we're only interested in the inputs and the outputs. So function composition is composing functions together. So rather than writing one big function that does all this in one go, what we do is we write a number of smaller functions and we compose them together to give us that functionality. So we have much more reusability of functions. So the 3 functions here are get purchases, that takes a customer and returns a tuple of customer and decimal. We've then got try promote to VIP, that takes a tuple of customer and decimal and returns a customer. And then we've got increase credit if VIP, which takes a customer and returns a customer. And what I want to do is I want to compose them together. So I've got 3. I know what the types are, and thankfully, because I wrote these, the outputs from the previous functions match the inputs to the next function. So if I want to compose them together, the way that we do it in say C# would be, I would take the get purchases function, I pass the customer into it. I'd then take the try promote to VIP, I'd put that into there, and I'd take the increase credit and do exactly the same thing. And I dislike this intently. Sorry. I find it very difficult to read. It also looks, from an English reader's perspective, it looks really odd as well. So I have to start here and then move here and then move to that. It's very uncomfortable to read this. So what people tend to do instead is we end up with promoted. Okay, so that's your second style. That again works, it's fine. It's better than the previous way, but it's a little there's a lot of repeated code there that maybe there doesn't need to be. So what we have instead in F# is we have the forward pipe operator. Oops. So the forward pipe operator is a bar and a greater than. And again, because I'm using a ligatured font, I get a nice pretty little arrow. So this uses partial application. So what happens is I take the customer, I then the customer gets passed as the parameter to get purchases, and the result of that gets passed on down the line to try promote to VIP, and the result of that gets passed on to increase credit if VIP, and that automatically happens. So this is something that you'll use a lot, the forward pipe operator. It just makes life really nice and easy. It's very readable. And you can see that it's a pipeline operation. So we're building up a a more useful function out of smaller functions, we're composing better functionality.
On this note, there's also in the latest version of F Sharp, I think it was F Sharp 8, no 7 maybe. There was some improvements on the piping, the debug breakpoint. So now you will be able to, go step by step on your pipes, and you will see the result generated at each step. So
Yep.
that you can use it in VS Code and write and in Visual Studio.
Thank you. Okay, so one of the things we can look at is, what is the forward pipe operator? So this is actually quite interesting because it's really simple. So it's actually defined inside the core language, but we're going to have an attempt at doing it ourselves. So the forward pipe is actually a custom operator. So it's defined like this. The way that it works is it takes a value and a function, and then it applies the function to applies the value to the function. So you actually run the function. So if you look at the signature over here, this tick A is the F# way of showing it's generic. So not generic as in generics in .NET, but generic as in it can be anything. So this signature is saying that if you supply something of type A and the function that converts something of type A into something of type B, then the result of that is something of type B. So the way that gets used, so if I go back to my add functions again, so if I find actually I don't want to use add, do I? It's got too many. So if we take the first one here, then, so customers and get purchases. So did I say it was purchases initially, wasn't it? Purchases. So the way we'd use it is like this. So we get customer and I don't have my customer, do I? Right. Right, so I've created a function called purchases that takes a customer as its input, and then we're going to use the prefix version of the custom operator. So it takes the value, which is the customer, and it takes the function, which takes a customer, returns a customer in decimal. But we don't use it like that. We use it as the infix version. So it's exactly the same thing. So we take customer, passes it through to here to get purchases, and that's exactly the same as just calling the function as you'd normally expect to call it. So those three things there are equivalent. So normally you just do this, but to be able to use it in a pipeline with we can use the forward pipe operator. So we can just pass it forwards. But actually it's a custom operator, so it's done slightly differently. But it's a really simple function again, but it relies on things like currying and partial application. So a lot of the things that we'll cover over the course of these 12 weeks seem very complicated, but actually they're very simple. They're very simple things to implement and understand eventually. But they're just slightly different ways of thinking than you're probably used to.
I think we have a couple of questions, but I think you kind of already answered, but I'm going to read it anyway.
Okay.
So there is one that says, if there's any case when you cannot use the pipe operator and chain functions.
So yes, there are some situations. There's some we'll cover later on once we get onto computation expressions. So there are. So at the moment we're in happy world. We're in the world where inputs and outputs match, but we're not going to be like that. So the next session we're not going to be like that, but we're still going to work with the forward pipe operator.
Yep, that's fair enough.
Yeah, there are situations where it is more difficult to do, but actually, if you can't, it's generally suggesting I generally think that you're maybe trying to do something a little bit out of the ordinary. It's hard to say. I can't really say that it's it's really a natural progression. If you write small functions and you compose them together, the way that you compose them together is generally through the forward pipe operator of one kind or another.
Yeah, my personal experience, like when you have a clear, well-defined functions, you can always know that the return type of the previous function is going to match. You design it in a way that you are going to make them match, so you are going to take advantage of the pipe operator.
Okay, so there is one thing. So if, say, for instance, the get purchases returns a customer and decimal, but try promote to VIP required a decimal and customer. So say you swap them over. What we can do is, remember I talked about get used to using the fun keyword. So what we can do is, if you use fun, what you've then got is access to the data that's come from the previous line. So in this case, we know that it's a customer. Actually, but it does do. So I could actually do In this particular case, it's just going to be the same again because they're not changing. But I can do things like that. So
Yeah.
if things are just swapped over, for instance, or you haven't got, it's not in a perfect order, you can do this sort of thing quite easily. The other way to do it is to write a wrapper function around the other function that does it for you exactly the same way. So if you're going to use it a lot, write a wrapper function. If you're not, do it like this. So these are all everything that we're going to come across, because it's all simple functions and matching outputs and inputs. All of this has been carefully thought about. There are always very simple ways of matching things up. It's very rare to get situations where you can't work in this sort of style.
Yep.
Do you say there are other questions?
There's last one from Dejan and says, when would you use a function composition over the pipe operator?
Sorry, when would you use?
Function composition. I don't know if it refers to the
The double arrow.
yeah, the double arrow.
Okay. I don't really want to cover the double arrow.
Yeah.
I
Not
deliberately
yet.
I deliberately avoided it in this session because I think it's not something you need to think about. So there are other ways of composing functions together.
Maybe just let me link the drop the
Yeah,
link in the chat, so you know, for now we don't don't confuse, you know, to get the natural progression, and
yes,
then we can cover this in the later.
yep. Okay, so the next side from this is, again, we're going to say, well, what's interesting here is that I've passed the function in. So this is exactly like using a func in C#. So we can pass functions in as well. So in this case, we've passed in the get purchases function. So if I take, so I'm going to do a quick let's do multiply as well. Okay, and then I'm going to create a little function called calculate. Calculate, that's going to take a function, two values. Okay, so this is a very simple function. It takes another function as input. Notice here again that it's a generic function, so it can actually take any type of function as long as the types match. It doesn't really care. So if I want to run that, so I can do result equals, calculate, pass in add 5 and 4. So note that this add 5, 4 is not the same as the add 5 and 4 that I did here. So this add 5, 4 here is running the function. In this particular one here, add is a function that's been passed in, and these parameters have been passed in separately. So it's not So it's not that. So I could change that to multiply. And what I can also do is I can supply an anonymous function. Instead, so I don't need to define all of my functions. If it's simple things like this, I can just create them on the fly. So that's called an anonymous function. So if I run, I'll just highlight those. So it's calculated add, it's 5 and 4, multiplies 20, and that's 1. So that's as far as I want to go with functions. Actually, no, it isn't. There's one more that I need to cover that I've forgotten about. So remember I said that all functions take one input, one output? What about things like void in languages like C#? So where there's no value being passed in. And obviously we can't do that because there isn't such a thing as void. So what we have in F# is we have something called unit. So let's think about the simplest one that we can do. So I'm going to open system. So it's .NET. So this is just like using in C#. And do now equals UTC now. So this obviously is a value. So if I run this, it's a value, it's fixed. So I don't want that. What I want to do is I want to create something that every time I call it, I get now, rather than the now when it was first run. So now F, and I'm going to use unit. Okay, so if I run that using Alt and Enter, so all that's doing is setting it up. And again, I can call it. So if I call as you can see, I'm now getting time. So we can use unit. So that's for no input. Well, what about a no output? So something like, I don't know, print into console. That'll do. If I do that, sets it up for me, so I can do okay, so unit is open bracket, close brackets. So printfn is a built-in function. It basically is a console.writeLine. And the output from that is unit. Okay, so are there any other things that we need to cover? So there are basically two types of functions in F sharp. You have pure functions and impure functions. So pure functions are fairly simply defined. So they're deterministic. So in a pure function, if you send in the same input, you get the same output every time. And there are no side effects. So it doesn't write to the screen, it doesn't read from a database, it doesn't, I don't know, doesn't pick up a date time now, for instance. So everything is, as I said, deterministic and no side effects. The majority of your functions will be pure functions. However, there will always be impure functions in there. There have to be. Otherwise, you'd probably not have a system that did much. So everything has to read from a database, right to a screen, that sort of thing. So what you're trying to do is write as many pure functions as possible, and then they're easy to test, they're easy to parallelize if you need to, they're easy to cache the results of, and then you write impure functions around that. I think that's all I want to cover today on functions. So these are the building blocks. So if you think about, this is a functional language, we have basically two things. We have types and we have functions. Actually, functions are types. So all the things you can do with types, you can do with functions, but functions are a specialized type of a type.
Yeah, we have a question that saying that David didn't quite catch what would you say that the pipe operator, forward pipe operator was using partial application. Could you go over that again, please?
Yep. Okay. Okay, so to go back, we need to cover currying and partial application. So currying is taking a function that looks like it takes multiple parameters and it automatically gets converted into a series of single input functions. So that happens automatically. So if we have a look at this function here, this add function. So add looks like, well, it does take two parameters, but it automatically gets converted into a function that takes an integer and returns a function that takes an integer and returns an integer. So partially applying would be to say you can do add and X. Well, actually, you can do partially apply. You can actually just call the function without any parameters. That would be partially applying, but you're just then returning the function in effect. So partially applying would be to say, just apply the first function, and you get a function out of that that takes the next function and will return the result when it gets that second parameter applied. So when we get to the forward pipe operator, what that does is, if partial application didn't work, you wouldn't be able to do this. You wouldn't be able to just you would just be able to put the name of the function in. So get purchases doesn't get run until the customer is applied to it, and that's what the forward pipe operator is trying to do. So the forward pipe operator takes a value and a function. Now, in this particular case, we've got this particular function. So this get purchases function only has one parameter. Now, it could be that get purchases had two parameters. So if get purchases had two parameters, I've got two choices. I can either pass both parameters down through the forward pipe operator, which is what happens on the next one where we've got the customer in decimal, or I could have that second parameter here. So if, for instance, get purchases requires a I don't want to change too much here. So if get purchases say required a another parameter like a key or something, and then needed the customer and the spend, or the customer and the purchases. So what you could do is you could put that second parameter here. And then when you forward pipe it, so this is that's still a function. So remember, when a function is partially applied, it still returns a function. And it only returns a value once it's received all of its parameters, all of the required parameters that it needs to run. Does that make?
Yep, that makes sense to me. It's I always basically it's amazing because the compiler will be changing the return type of the function itself to tell you what is the value missing. So as you said, if you apply, if you partially apply a value to the function, then the whole signature will change and everything won't be executed until you provided the last value.
Yes. So the thing that you need to keep looking at is to keep looking at the inline
hints.
What do you call them? Hints?
Yeah, inline hints.
Yeah. So the inline hints that IronHide and the compiler are giving you. So in this particular case, it's telling you that that's going to return a customer star decimal. Now, if you got something that was partially applied and you haven't applied everything, what you'll see is you'll see arrows in there because it will still be returning a function.
Yep.
So it's important to keep an eye on the hints and to work out where you've got functions and where you've got values. So where you've got a value, you just get one thing back, whether it's a tuple or a record or an int or whatever. But where you've got a function, you'll see arrows.
Yep.
So that's a hint. That's telling you that what the type is at that particular point. So it's important to get used to these. It's important to be able to read things like the definition of the forward pipe operator and be able to see that what that signature is actually telling you.
Yep. Going back to the unit part that you were explaining, just to end the session, is like I normally there's the key difference or key important concept is like a value when um, it's always evaluated when at the module level. So if you have a value, it will always be executed. So if you are the unit, that basically will be a lazy evaluated. So it means that it won't be called right away when you are compiling the code. It will be called when you are actually using it, like you describe it in online 67, I think is.
Yep.
So yeah, there are basically that's the what took me maybe a couple of months to realize when I was learning F sharp is like why I'm getting this value executed when I didn't even realize. It was like just because of the unit.
Yeah, so if I call um so if I call now F but without the unit parameter, what it's telling me is it's returning a function.
Exactly.
So it won't actually work until I actually now have to call not complete to get it to complete.
Yep.
So one of the interesting things from this is that the difference between a value that's immediately evaluated and a function that isn't is we can actually use scoping to help us with some of this. So say, for instance, I've got a random number generator. Or something that that maybe takes a little bit of time to start up. So, or I only want one instance of it. What I can do is I can create the random thing inside what looks like a value, but then I can actually run a function so it's still a function, but what that's going to do is when it runs through the code first time, what it's going to do is it's going to create that little random value, and then only when I call the function with the unit will it actually operate.
Yep.
I'll call that so I can do things like I'm going to need to cheat here. I'm going to jump ahead of myself. And do print. Oh, I'm not going to bother with that. Yeah, so I can do stuff like that. Again, it's the same things being reused all the time. So getting used to using things like the fun keyword. So creating functions in that way. You don't do it that often, but yes, they prove to be quite powerful. The other one as well that I didn't cover that might be worthwhile looking at is this one. So we went to a little bit of effort to write these some function signatures like this and define them, but we never actually used them. Now we've got enough knowledge to be able to do this. So if I copy that, okay. So what I'm going to do here is I'm going to use the calculate total definition, type definition. So let's use like so this is how we use the function type like that. So the function calculate total uses calculate total type signature. So I can get rid of these. They're not necessary anymore, because it still tells me what the type is. So that's how I use those. So again, it's using the same little tools. And that's what we'll find all the way through. That all these little things that you look at here and think, yes, that's nice, but it doesn't really do anything. Actually, as we get further into it, you'll find that they're really useful.
Yeah, definitely. Callbacks, closures, all of that is a useful tool. We will cover. We have planned for the once we have we go over the 12 sessions of essentials. We are planning to have some bonus sessions about desktop development, web development, mobile development, and in there we will develop mobile apps or desktop apps that will use a lot of side effects, like making HTTP calls, like getting to the parse or convert some data, transform some data. So we will see a lot of side effects there in a quote unquote real world application. So that's awesome. I think we are good for this session, Ian?
Yeah.
Nice.
I don't want to go anymore. So the next session will build on top of this. So all of the things that we've covered in here, so the pattern matching and all of the function stuff that we've done will all be very useful in the next session.
Right. Thank you very much, Ian. I'm going to take it over, and I'm going to just say a couple of things. So let me share my screen, and we will just finish the session. So thank you, everyone. This was the second session of the Essential Lectures. Yeah, join us for next week, where we will be covering, let me go to the Essentials landing page. Next week, we will be covering function composition with effects. Is that right, Ian? Oh, no, is it dive into collections, I think?
No, it is function composition with
All right.
effects.
Perfect. Yeah, so next week, join us for the third session. And again, I will update the links, the date, and all of that will be ready. So before I let you go, just a quick reminder, Amplifying F# has Friday sessions where we focus on fixing specific issues on the F# ecosystem, like compiler errors or tooling errors, or any issue that a maintainer or a contributor is working on the F# ecosystem. So for this week, we have I myself will be attempting to contribute to the F# compiler to fix an issue that it has been bothering me for the last 2 years. So, what better chance now to join the session with us, which is a group of F# contributors that we will try and fix that issue. All right. So with that in mind, let me